for humanities data structures that you will use in Python, but it's just going to be a lecture style presentation. So just relax, don't do anything. And then in 10 days, we'll have a 3D Python workshop. So there are 3 follow-up sessions on February 26th to February 28th. And for these, you need to register separately, but they're meant really to be follow-up sessions to this presentation. So there we'll have 6 hours of instruction. We'll have lots of exercises, lots of hands-on, but today just relax and watch the presentation. So why Python? Well, Python, you heard about Python a little bit this morning in the Jupyter session, but Python has emerged in the past 15 years as probably the most popular language for scientific programming, independently of the specific scientific field. So it's an open source programming language that was written actually quite a while ago. So it was first released in the 1989, 1991, I can't remember, but it's almost 4 decades now, and it's very high level. And it has lots and lots of libraries now. So with Python, you can do things like these in a few minutes. So you can analyze thousands of texts, and by text I mean, I don't know, a novel, like a full-size novel. In a few minutes, you can process billions of records, in a spreadsheet. You can manipulate thousands of images. You can restructure and process data pretty much any way you want. So when you compare Python, for example, to Excel, I know that a lot of people here have experience with Excel. So Excel is a proprietary solution, and obviously it works with Excel spreadsheets. So if you compare Python and Excel, there's just absolutely no comparison. So unlike Excel, Python can process pretty much any type of data, both structured and unstructured. So anything you can save, any data you can save in a file, Python will be able to process it. So Python has hundreds and hundreds of really fantastic libraries, for all sorts of purposes. It's free, it's open source. Open source means that there are no artificial limitations on where and how you can run. So it's opposed to Excel or other proprietary software. It works on all platforms. So whether on Windows, Mac, or Linux, you can install it natively and just run it on your computer. I sometimes run Python on my cell phone if I need to compute something very quickly. It's accessible there as well. And data manipulation in Python is just so much easier than in pretty much any proprietary solution. And you will see many examples today. And of course, Python also has all the benefits of being an open language. It's more reproducible, so you can just take the data and the script from somebody else, from your colleague, and run it and get the same or maybe different results. So if you compare Python to other programming languages, and you heard some of this morning a little bit, it's very high level. It's very easy to learn. It's very fun to code. It supports interactive sessions. So it's interpreted language, meaning that you can enter your line, a line of code in Python into the shell or into a Jupyter notebook, and then hit enter, and it will run, and you will see results immediately. And it's very easy. It's fun to play with. As I mentioned, there are hundreds and hundreds of libraries that are relevant to people doing research in humanities and social sciences. One big downside of Python is that it's slow. So being an interpreted language, interpreted meaning that translation into machine code happens at runtime, it's slow compared to traditional languages like Fortran and C, but there are many ways to speed it up. So one of the ways is to use external libraries. So typically, Python external libraries are written in, not in Python itself, but in languages like C or C++. And therefore they're fast. So if you spend most of the time in a Python library, then your code can actually run almost as fast as if you wrote it in a compiled language like C or C++. So another big, kind of big. So some people, for some people, it's a major problem is that it uses indentation for code blocks. So for example, if you enter a for loop, if you have a function, if you have an if statement, you will use indentation for code blocks. And people who grew up with languages like C and Fortran, they don't like it because it looks different. I guess if you started programming Python, you'll get used to it very quickly. But this is something to keep in mind. So installing Python is probably one of the most difficult things you will see today, and we're not going to be installing Python on your computer because for that we'll have the hands-on workshop in 10 days. But installing Python, so if you're doing research in humanities, social sciences, I really recommend that you install, not now, but later on, that you install Python on your own computer, because then you wouldn't have to go through, a Jupyter Hub interface, for example, to log in to a session on a cluster like you saw this morning. You can just run pretty much everything, natively on site, inside your computer. And there are 3 major ways to install Python on your own computer. One is you can go to python.org, download session, and And there are links for your operating system. So for example, I'm on a Mac, and most likely I just get automatically mostly links from Mac. But there are links for Windows, Mac, Linux, and you can install it. So one thing that you want to make sure, this is really important, and I deal with it quite often when I teach in-person workshops, is when you go this route, you want to make sure during the installation process, you want to make sure add Python to path. And this is important because later on to install libraries, third-party libraries, you will have to drop down to a shell or to a DOS prompt or to Linux prompt or a Mac terminal prompt and install libraries there. And to be able to do that, you actually have to check this option when you install Python from via python.org. A second installation option is easier. It's by Anaconda. So Anaconda, and then there are links here in the workshop notes. Anaconda is this Python distribution, which also packs a lot of third-party libraries. It's a huge download. Typically, it's something like 4 or 5 gigabytes. It takes a while to download and install it, but once you install it, you'll simply go to Windows to start menu, and then you can just use it as is without installing any other software. And then you can also install Python via your favorite package manager. So I don't know, I'm not familiar with Windows Windows package managers, but in macOS, for example, I use a Mac. So there is Homebrew. Once you install Homebrew, you can do commands like brew install Python. If you're on a Linux machine, then there are package managers for various Linux distributions, and they just install Python very easily. And that's probably the easiest option, assuming that you have a package manager. So as I said, all of this, so installing Python, you have to do it only once. It can be quite tedious, take some time. But once you install it, everything is much easier after that. So starting Python, so there are 3 major ways to run Python. This morning you saw a Jupyter Notebook or Jupyter Lab interface, and I'm going to be using Jupyter Notebook in today's session to show you the examples. But just to show you that you can also run Python in other ways as well. So here I open, this is a terminal on my notebook in macOS, and here I just start Python. In my case, I have Python 3.11, and here I can just type Python commands and print 1 divided by 2 or whatever. I can enter Python commands here, and I just run, right? So I can just run Python interactively in any shell terminal environment. So I'm going to exit it, and I'm going to show you the second way. So you can also store Python code inside text files. So here I have a simple file called test.py. So py stands for Python code, and here I have a very simple file which is executable. So on my macOS, I can do ls-l, and you see there is the executable bit turned on. What it means is that here's the Python code. There are just 2 lines of Python code. All right, and I can just run it as an executable. And in this case, it imports a math library and prints this sign of 5 radians, right? So here's the answer. Very easy. So just pack your Python script into your code, save it as a text file, and then just run it, make it executable, and then just run it from the shell. But of course, because the third option is easier than the previous 2, and it's really, really interactive. It lets you do graphics right inside your notebook. We are going to be using Jupyter Notebooks. So to start Jupyter Notebooks, you can do it in a number of different ways. You already saw the Jupyter Hub interface, for example, jupyterhub.ceda.computecanada.ce. So here I could log in with my Alliance account, and then I could start a job asking for so much resources and so much runtime right inside this form. And then it will give me a dashboard in which I would select a Python interface and a Python notebook, and then I can run my Python code there. So as opposed to doing that, I'm just here. I'm just going to start a local Jupyter notebook. And the way you typically do that is once you install Python, once you install Jupyter and the libraries, you say Jupyter notebook. So the interesting thing is that on macOS, on most recent version of macOS, this is broken. So this command actually won't work for me. So you will see I'll get an error message, even though this is the documented way of doing this, but it's a bug somewhere between Jupyter Hub and macOS. I'm not sure where it is exactly. So in my case, I will need, and I'm just giving this information here just in case if you run into a similar problem. Once you install Python and Jupyter on macOS, if you run into an issue like this one, this is the way. So this command is actually notes, the way to start it in the most recent version of macOS. And basically what it gives me inside the browser is this dashboard that you saw a similar dashboard this morning in the Jupyter session. Here I'm going to click on Notebook Python 3, and it starts this Python 3 notebook where I can just enter commands. For example, I can say print 1 divided by 7. Let me make the font bigger like this, and then here we have the answer. Let me actually split this into two windows and minimize this window. So I'll be copying now a lot of code from my notebook, well, not from my notes into this Jupyter notebook. So I won't go through the commands to navigate the Jupyter interface. They are here, and also some of them this morning. So to get help on anything Python, it's super easy. One way to do this, you can enter help command, and then inside brackets you will have the the code that you want to get help on. For example, in this case, I want to get help on the print command, and it will show this help right in line. So you see that it's a function to print stuff, right? And then takes these arguments. Inside Jupyter Notebook, you can also enter question mark, and then say, I want to get help on print, and this will open, a similar interface. It's actually presented better inside the notebook. It's color coded, but this is yet another way to get online help for Python right inside your notebook. So Python is a high-level language, right? So that means that you can actually do a lot of stuff in just a few lines of code. And it's also a dynamic language. So dynamic language means that any variable that you define, you don't need to define its type. So in this case, I'm saying a is equal to 1, and it automatically becomes an integer type variable, right? So if I say type of a is just an integer variable. So if I want a to be a string, so now I see a is equal to a value, and then type of a is a string variable. So here I'm not going to talk about these basic variable types. I'm going to talk about, show you a few composite variable types. So let's talk about lists and dictionaries, because these are the data structures that you will probably use most often in when you program in Python. So a list stores many values in a single structure. So let's say we have a list of events, right? Assume these are years, just some random list of events. So the way I initialize a list is I have square brackets, and then you just apply a bunch of values inside, well, as a list separated by commas, right? So in this case, we define the events list, and then if I want to print it and say events, or I can say print events. So in this case, these last two cells are exactly the same, or almost the same, right? So they both print the value of events. So in general, in Python, if you want to print a value of a variable, you should say print. So here I just say events, and the reason it works, if you have some code inside a Jupyter cell, then the very last thing will be printed. So this is the very last element in the cell, and it's going to be printed even though that I don't have a print statement. But sometimes when you have a more complex code and you want to print something from the middle of the code, you actually have to use the print statement explicitly. So this is a list, right? And the list, has a number of things you can inquire about. One of them is number of attributes. One of them is the length, right? So you can say, please give me the length of the events list, and it has 10 elements. The first element is to access an element of a given position. Let's say the very first element, you say events and then square brackets. In Python, counting starts from 0, unfortunately. So that means that this is actually going to be the 0th event, or events, right? Because I define it this way. So this is the very first event. If you want to say, I want to print, all values starting from 2 going to 5, but not including 5, I'm using, again, events. I will need to use this syntax. So here, the way counting works is I'm starting from element with the index of 2, which is actually element number 3, because in Python you count starting from 0, right? So here is 1772, and then start from number 2, go all the way to 5, but do not include, actually in this case include, actually include 5. So 0, 0, 1, 2, 3, 4, sorry, do not include 5. Go all the way to 5, but do not include 5. So give me 2, 3, and 4. So you can also modify elements inside a list. So a list is a mutable structure in the sense that here I can just say, here is element number 3, and I'm going to override it. So previously element number 3 was 1772, and now I just override it. Now it's 1773. So with a list, any list, you can access a number of functions that are built into this list using these dot notations. So if I give tab, Jupyter gives me a bunch of functions that I can use, right? One of the functions is append that will add an element to a list. So let's append a couple of values, for example, 1239, and let's append another value, 606. So now in my list, I have two additional elements. And then if I print a list, now you see that we added two elements via this dot append function. To remove elements, you can use either pop or remove. So events pop will remove an element at a given index, at a given position. So remove element number 4, right? So if I do this, remove element number 4, so 0, 1, 2, 3, 4 is going to remove 493, right? So if we do that and then print events, you see that there is no 493. And then if you want to remove by value, you will use the remove dot remove function. So you're going to say events dot remove, and then I'm going to remove, let's say, this guy, right? 1788. Then I pass it as an argument to the remove function. Oops. Events remove 1788. It's not in the list. Oh, because it's not actually not a string, but a number, right? So I attempted to remove it as if it were a string, but it's actually a number. And now if I say events, now you see that 1788 is no longer there. So lists can be inhomogeneous. This is an example of a homogeneous list in the sense that all elements are exactly of the same type, integer in this case. But you can also have, you can also mix elements of different types. So here I start a list, an empty list, right? Just empty square brackets, right? And if I do that, that is still a list, right? So I can say it's a list, it just doesn't have any elements. And then I can append 3 elements. I can append an integer, a string, and a floating number, right? And in this case, if I print A, you will see that it includes all these. It doesn't have to be, the same type of element. And lists can also be nested. So in this case, I append, what do I append? I append a single element. So as you can see in brackets, when you use the append function, you can append only a single element at a time. So here, for example, in the previous example, when I appended things twice, right here, 1239 and 606, I actually had to call this function twice because you cannot pass 2 arguments to append. It takes just a single argument. But here I'm appending a bunch of things. And the reason I can do this is because I'm still passing single argument. So notice that what I'm passing here is in square brackets, which is a list, right? So I am appending a list as the last element in my original list. When I do this and I print E, you will see that now element number 3, so 0, 1, 2, 3, is actually a list, right? So in order to access this element, I'm going to say E of 3, and it's going to print me the value. And also in Python, in order to access the very last element of a collection, you can use negative indices. So -1 means the very last element. So the idea is that 0 is 1, and then you start going to the left, counting, decreasing the index, and it's going to be -1, -2, -3, and so on. So -1 is always the last element of a collection. And if you want to access, let's say, I don't know, Venus, then you can use this notation. So Venus is going to be number 1 in this list, right? So -1 will give me access to the list of planets, last element in E, and then 1 will give me the second element in this nested list. So in Python, you can have this very, very nice syntax where you can just check if something is present in a collection. So let's see, is Venus is present in the last element of A? Well, it is present, right? Because here's Venus. So it says, yes, it is present, and it gives me the true, it evaluates to true. So what I type here is actually a condition. It's a conditional statement, and it evaluates to either true or false. So if I pass another planet, let's say, I don't know, Neptune, is going to return false because Neptune is not in this collection. If you want to get the index of an element, you will use the .index function. So here, for example, what I'm doing in this notation is in the original list E, I'm going to the very last element. E of -1 is the very last element. And then I'm saying, please give me the index of Venus in the very last element of A, right? And in this case, it should return 1 because Mercury is 0, Venus is 1. Right? So here it will give me 1. With lists, you can also, in Python, there is a nice way to create new lists, which is called list comprehension. And it's really fantastic. I use it all the time. And it lets me create a new list based on existing collection. So let's say here I have a range of numbers. I'm going to say range of numbers. And when you say range 10, it gives you a list of a range of integer numbers from 0 to 10, but not including 10. So 0 and then 10 numbers up to 9, including 9. And then here I'm going to say, for I in this range, please give me I. And what this will produce is a new list, right? So with notation, a list comprehension, I'm creating a new list that has all these integer numbers from 0 to 9. Let's say if inside of these numbers, I want to include their squares. Well, in Python, notation for squares is 2 asterisk, and here I have 2 square. I have squares of all integers from 0 to 9 inclusive. And with this, you can actually form more complex collections. So, for example, I can say, please give me integers. Please give me integers of all numbers from 1 to 10, not including 11. Compute the squares of those numbers and put them into a list, but only if the original integer number is not an even number. So if it's an odd number, and then put it into the resulting list. And here's the answer. So I'm going to skip these examples. So here the point is that in Python, you can actually solve a problem in many different ways, right? So for example, let's write a script to get the frequency of all elements in a given list. So here we have a list of integer numbers, and we want to get a frequency of, let's say, 77, of 9, and so on in this list. One way to do this is to use the built-in count function. So here we see count how many times 77 occurs in the list. Well, it occurs once. How many times does 9 occur in the list? Well, twice, and so on. So here we can actually organize a loop where we go through all elements, and then, so here we go through all elements in A, and then we count how many times this element is present in the list. But the problem with this code, and notice, by the way, that it didn't print anything. So the reason why it didn't print anything, and I mentioned this before, is because in this case, we have a longer code, and we need the print statement. So here, notice that it's actually redundant in the sense that for those elements that occur more than once, it actually prints them more than once as well, right? So here we have 77. Actually, no, here we have 9, here we have 9, and here we have these counts, twice. And that's kind of redundant, right? So in order to get rid of this redundant output, you can use a set, for example. So a set is a different type, is another collection. So here I have the original list, and let's print a set formed out of this list. What a set is essentially the original list, but it only includes unique elements, right? Whenever you convert any collection to a set in Python, it returns only unique elements. And then here you can actually, count these, and you will not see any redundant output, right? Because now we are counting things not in a list, but in a set formed out of this list. Another solution is to use a third-party library. So here I'll just paste it, and here we're using a third-party library called collections, and here we have the counter for those. What it returns is a dictionary. We're going to talk about dictionaries in a second, but it returns a dictionary where, to each element, for each element, it gives me the frequency, how many occurrences we have in the original list. So dictionaries are also collections, but they're quite different. Lists are ordered sets of objects, right? Ordered sets of objects in the sense that if you want to get, let's say, element number 3, let's say 0, 1, 2, 3, this guy, you say, A of 3 in the square brackets, and give you the element number 3. So dictionaries are not ordered, and the way you access values in a dictionary is via keys. So a dictionary is essentially a set of key value pairs, and they are unordered. You cannot use indices to access individual values. You use keys to access individual values. So let me give an example. Let's actually start with lists. So here we have a list of names, and then for these people, we also have a list of their favorite colors. So both are initiated as lists, right? So we have a list of names and a list of colors. And looking at these two structures, the problem we have here is, let's say, for a given person, let's say Eric, want to find out his favorite color. And it's kind of, difficult to do this working with lists because there is no, one-to-one correspondence. Well, there's no easy way to get, go from a name to a color. So what you'll probably have to do is you're going to say name, and then you have to get the index of Eric's name in this list, right? So I'm going to put it into quotations. So name index Eric names, right? Of course, index. Oops. So I have names, and then I'm going to say index unmatched. Okay, now it works. Not sure why it didn't work previously. So by the way, often people ask whether you should use single quotation or double quotation. In most cases, not always, but in most cases, actually, it doesn't matter. You can use them interchangeably. You can use either single quotes or double quotes. So here we get the index of Eric in the first list, and then we can pass that index to the colors list, right? And then as a position, and then we get the blue name. But this is kind of complex because I have to go through these multiple calls of functions and indices. And dictionary, let's actually address you this problem directly. So what you can do is you can start a dictionary, and unlike lists, dictionaries in Python start with curly brackets. So if I see type, and here I have a dictionary of favorite colors called fav, its type is a dictionary. And then you can cycle through all elements in names and colors. So here what I'm going to do is I'm going to cycle this zip collection. Let's cycle through names and colors simultaneously. And then these become name and color. So now actually let me show how this works. So if we do this and then we'll say print name and color, it will cycle through, name and color. It will cycle through both names and colors simultaneously, right? And then we can actually use these variables name and color to assign values to keys and assign strings to keys and values in the dictionary. So here what we're going to say is we're going to say favorite of name is equal to color inside this loop. And when I do this, now we have a dictionary that simply gives you the one-to-one correspondence. And the way you use it is you're going to say, let's say favorite for, I don't know, Jeff, right? So for Jeff, what's his favorite color? Well, here's burgundy. Let's say for Mary, what is your favorite color? So there's a one-to-one correspondence between the two lists, right? Very, very easy to follow. With dictionaries, there are usually multiple ways of encoding things into a dictionary. So here, I'm going to show you another way to do this. So let's say we have now three lists. So we have, for each person, we have three essential attributes: a name, a color, and an age. And let's say we want to encode that into dictionary. So obviously using the previous data collection, you won't be able to do that because here we have a key and a value. There's nothing else you can supply to a dictionary, but now we have a new attribute called ages, right? So how would you encode this into a dictionary? Well, it's very easy. I just have to approach it from a different point, from a different perspective. So instead of using a dictionary as an encompassing data structure, you can use a list, and then for individual people, we'll have each element will be an entry in that list, but the value is going to be a dictionary, right? So it's going to be a list of dictionaries. So here we have a new list called data. Now it's empty, and then we're cycling through the three collections, names, colors, and ages simultaneously. And then we're extracting, for each position, we're extracting the name, color, each person, we're extracting the name, color, and age. And then we are appending that into a new element, which is a dictionary in this list. So when I do this, and when I print data, you see that now my data is a list, right? The encompassing data structure, outer data structure is a list, but now each entry is a dictionary. So this is a dictionary, right? For a person, this is a dictionary for a person, and so on. And then we can easily access, each value we can say person is equal, let's say data, let's go to the very first element. This is person number one in this collection, and then we can say print person, or just person, right? And it gives me all three attributes. Or I can say person, let's say name, right? The name, I can say person color or person age, and it gives me those attributes as well. Now, if you want to search for things, it's slightly more complex with these data, this organization of data, because previously we could just say, favorite color of Mary, and it gives me orange now, but now we have more attributes and things encoded in a slightly different way. So here you can do it in a number of different ways. For example, you can cycle through all people in my database of a person in data, and then I'm going to say if person's name is equal to a value, then print the color, favorite color, and age, right? So I can do things like this. So very, very easy, right? So and here it returns data for Jeff. I could also do this in a single line via list comprehension. So here I have a collection data, right? So I'm cycling through this collection for a person and data. So for example, if I do this, that will just print me, this will just print the original list, right? So if I say person, for person and data, I'll just print the original list. But I can also, at the if statement, I'm going to say if person's name is Jeff, then please return a tuple, so return a single element. Tuple is a collection of elements, but it's immutable, unlike a list. So basically return here the favorite color and the age, right? And I do this in a single line. And it just works, right? Magically works. So this code and this code do exactly the same thing. So as you can see in Python, for doing, I think there are usually multiple ways of doing this. And if you try to do this for a larger data collection, so here we have just, how many, five entries in this list, five, people in the database, it's, quite easy to do that using, this code. But if you have millions or billions of records, then you find that, this way or this way of extracting data is slow. So you probably want to use a code like this one, which is, a more Pythonic way of doing things faster. So here what I'm doing is I initialize, and again, I don't expect you to, understand this completely, but what we're doing here, we are using a so-called lambda or anonymous function that simply maps, an item, let's say person, an item in our list, to a certain conditional statement, right? So if the person's name is equal to Jeff, then so this is the function, right? Which simply takes the person entry, person in our collection, and then maps it into either true or false, depending on whether that name is Jeff. And then we apply the function to each element in the data. And then what this filter function does, it returns an iterable, basically a collection of things that only correspond to where the outcome of this function returns true, right? So basically, it's a collection of all entries where the name in the entry is equal to Jeff, and then we convert it to a list. So if I run this, that will simply print the entry for Jeff. And this is, if you process millions of billions of records, this is actually a faster way of doing that than using either this or this approach. So let me skip this stuff. Working with strings, there are many different ways of working with strings. So for example, here, if we have a string HSS winter series, we can do a bunch of manipulations here. So for example, I can say event, and then I click dot and then tab. It says, these are the things you can do to an event. For example, you can use the capitalize function. What does capitalize function does? Well, it simply puts the first one, makes the first character uppercase, and then everything else is lowercase. So here I can count the number of occurrences of S inside, in a capital S inside the string. You see there are 3 occurrences, right? And it returns 3. So let me find the first, the index of the first occurrence is sitting at position number 1, starting from 0, right? If I want to replace, let's say, HSS, which humanities and social sciences, I use the dot replace function. And when I do this, now inside event, I have these, right? So HSS becomes humanities and social sciences, and so on, right? So many, very easy to manipulate strings, to, search for a substring, to replace a substring, and so on. So I'm going to skip this because I have tons and tons of more material, and I just want to show you more exciting stuff. So in Python, typically, as I said, in order to get something interesting, to get the most performance, you probably want to work with libraries as opposed to native code, because libraries are precompiled. They're typically written in a compiled language like C or C++, and they're just faster than a native Python code. So in order to load a library, you will use the import syntax, right? So here, for example, if I try to print the value of pi, well, it gives me an error message that says pi is not defined. And the reason for this is because pi is, it could come from a math library, or NumPy library, or some other library, but I have to import the library first. So here I import the math library, import math, and then I say inside the math library, there's something called pi. Please print that. And here I'm printing the value of pi, right? So there are multiple ways, there are multiple syntaxes for importing things from a library. So for example, if a library has a long name, you don't want to type, its full name every time, you can give it an alias. Here I'm importing math and giving it the m alias, and then I'm printing the value of pi as m.pi, right? So installing Python libraries, typically you would do that with a Python pip command. So pip command is usually installed when install Python, and then you open a terminal, and then you'll say pip install, and then the name of the package. And you can do that in Windows as well if you check the box that I mentioned at the beginning, where you make the command line utilities available to you in the prompt. So when you work with multiple libraries or multiple projects, it's a good idea to create virtual environments, because these will let you separate different projects from each other. So sometimes you will find that as you keep using Python for different workflows, you might find that there are certain collisions with libraries. So sometimes certain dependencies collides with another dependencies. I have to install things. So an easy way to deal with it is to create a virtual environment, and then you can install libraries into a specific environment. And then if you want to switch from one project to another, you just terminate the current environment and then load another environment. So these lines in the notes show you how to do that exactly. So a quick overview of some external libraries. NumPy library is really fantastic. It's a library for working with large uniform data collections, including multidimensional arrays. Why this library is so important in Python is because Python is actually not good for working, native Python is not good for working with uniform data collections. So you saw examples of lists and dictionaries, and those are fantastic, but they're very high-level data structures in the sense that they can be very non-uniform. So, for example, a list can combine many different types of variables, and then in order to get in order to actually read or write into the variable, Python has to know the type of each element inside a list. And lists could be nested. They can be nested multiple times, and it can get very, very, very complex. But of course, the price for this complexity, it's very easy to use lists in Python, but the price is performance. So once you start, initializing lists with millions and billions of elements, they will become very slow. So the solution for that is to use NumPy. So NumPy lets you work with very large uniform lists, and in a uniform list, in order to access, let's say, element number 1,000, you don't really have to read all elements before that. You can simply read the type of a variable in a NumPy array, right? Let's say an integer typically takes 4 or 8 bytes. Then in order to go to element number 1,000, just go to 8 bytes times 999 offset, and that takes you immediately to that memory address of element number 1,000, right? So NumPy operations on NumPy arrays are typically much faster than operations on elements of a list, and that's why NumPy library is really one of the. If you're wondering, well, if you need performance out of Python, NumPy is one of the libraries to go to. And then there are various libraries that are built on top of NumPy. So Pandas is one example. Pandas lets you work with large data, spreadsheets, two-dimensional data collections, essentially two-dimensional tables. So here I have an example of a data table that I put online in my GitHub repository, but essentially public domain data. So it's some data in tabular form for Jeopardy questions. It's a 31 megabyte file, so when I actually read it, it's going to take a few seconds, but probably not too long. So here it is reading. You see the full circle. Right now it is reading the data, and now it's read, right? So now if I inquire about the shape of these data is now a data frame, because now we jump into Pandas. Now it's a data frame. It's a table that has almost a 250,000 of rows and seven elements. If I'm curious about seven columns. If I'm curious about the names of the columns, I can say data.columns, and these are the columns. So basically, this is at least a table of Jeopardy questions, and the individual elements in the table or columns are show number, air date, round category, value, question, and answer. So if I want to print the entire table, I can do data, and of course, with 250,000 or so rows, it doesn't print the whole thing, just prints the few lines from the beginning, few lines from the end. But I can access any elements very easily. I can subset any element. So let's say here I'm going to show only rows from 2 to 4, right? So this is the familiar Python notation you saw for list before. So starting from row number 2 and go all the way to row number 5, but not including row number 5. So let's look into the category column. So in the category column, we have all these rows, so 250,000 rows, and then we have history, and so on, different categories. Let's only look at those rows that have a history for their categories. I'm going to say data category, I'm going to say equal. So that's a that's a conditional statement to history, right? And that what this will return, it will return this number of entries, and individual entries are going to be either true or false, right? So whether history is present in that or not. I actually need an uppercase history in order to make this work, right? So now we have either true or false, right, for individual entries. And then you can actually use this as a mask. So you can use this as an index in the original data frame. And that what this will return, it will return only those rows that have history in their category. So these are, the rows, and I can actually see immediately that there are 349 rows that have history for category. And then I can take this data, I can save it to a CSV file. How do I do that? Very, very easy. So actually doing all this manipulation in a single line. So I take a look at the original data table. I extract only those rows that have history in their category column. And then I save that to a CSV file called history.csv. So when I run this, and if I open my file manager here, now I should have a history.csv file, which is what I just did in a single line inside Python. So here's an example of slightly more complex manipulation. So let's check the time period covered by the table. So if we look into there is a column called add date in this table. And if I look into, let me collapse this, if I look into the column add date, it actually has this formatting, which has the month, the date, and the month, the day of the month, and then the year. But the problem with the years is that it's a 2-digit year. And actually, this covers a bunch of shows from both from the 20th century and 21st century. So, it's kind of difficult to extract things from it using ranges because you might have 99 and then the next year is going to be 00, right? So how do we deal with this? Well, let's take a look at the last column. Let's take a look at the first row first row in the table. In this column. So this is the add date column, and this is the first row or first entry in this column. And then let's extract the second to last element, which is going to be, actually, let's see, I'm going to extract the range here. Let's going to extract the last two characters from the string. So here's a string, here's a string. Let's extract the last two characters. So I do this using this notation, -2, and go all the way to the end, right? So here's how I extract the substring from a string. And then let's apply a lambda function, which maps, basically goes through all rows. So here we have another lambda function, which is applied to an entry in the add date column, goes through all rows in this add date column, and then it applies this lambda function, takes the entry, and then extract the last 2 digits. And so what this will do is, now I have this collection year, which has 216,000 elements, which is just the 2 digits. And then I organize a loop where I go. So here the problem is that these include years both in the 20th and 21st century. So let's say, is there, I can do things like this. If is there a year, let's say 65, I want to use the condition. So year is equal to 65. So here I have an array essentially, or a list of mostly falses. And just looking at this, I don't know how many entries are true, right? So what I can do, I can actually sum them up. And so falses were going to give me 0, trues are going to give me 1. And then apparently I don't have any values for 65. So how do I explore this? Well, one way to do this is just to loop through all years, right? So here I'm just looping through all years from 0 to 99. So this gives me all integers from 0 to 99. And then I'm extracting, so I take these 2 digits. And then, so the problem with this is, actually, let me do this. Oops, sorry. Let me erase this code. And then let me print y. So the problem with this is that, so it gives me all these integers from 0 to 99, but there are some digits that, there are some numbers that have only 1 digit. There are some numbers that have only 2 digits. And then, but to extract, to apply these to my table, I want to have only 2 digits in the output. And the way I do this is I simply convert a single digits into 2 digits using this notation. So now if I print this, oops, sorry. Now you will see that I have exclusively 2 digits for all years. And then I can say simply extract those entries in the year that are equal to a certain value of 2 digits. and then print their sum. So they will simply printing the sum of all truths will give me the number of years that have entries, corresponding entries in this table. And here's the answer, right? So here we can actually see what's going on. So here you see that it loops around the turn of the century, right? So for the year, for example, 2013, well, there's nothing for 2013. There's nothing for 1913. So the entries actually start from 1984. They go all the way to 1999, and they loop around. So they resume in 2000 and then go all the way to 2012. So image manipulation, there are several really good libraries for image manipulation. One of them is Pillow, the other one is skyimage.io. And both of these are also based on NumPy for actually storing the images as multidimensional array. So let me read an image. So here I have an online image, right, sitting somewhere in GitHub. And if I load this image into a variable called image, and inquire by the type of the variable, it says it's a NumPy array, right? So how do I visualize it? Well, I just say, actually, let me do image shape to tell me, to show the size of this array. So it is 1024 by 1024 image, and then it has what it is? Well, it is RGB colors, right? Red, green, and blue channels in this image. So every PNG image actually has 3 colors. And then let's display it. Well, very easy. I just call this command, and it will display this image, right? So here's an image that I can just display via NumPy and this scikit image library. Let's say I want to negate one of the channels. I'm going to negate channel number 2, which is the blue filter. So I'm going to run this simple NumPy operation to negate everything. And by negate, I mean subtract the values from 255, because this is a 10-bit image where individual colors are equal to integer numbers from 0 to 255. So if I run this will effectively negate the blue channel. So when I run this, as you see, it takes very, very small fraction of a second, and then I try to display the image again. You'll see, oops, you see that now I'll get essentially a negative of the image in the blue filter. So very, very easy to manipulate images, apply more complex operations to them, and so on. And then we have only 5 minutes left. So let me skip a few things, and let me talk about web scraping for the next few minutes. So with Python, you can do web scraping very, very easily. There are several very good libraries for them. One of them is Beautiful Soup. So what Beautiful Soup lets you do is you can, so in a library called requests, you can download data from a website, and then Beautiful Soup lets you pass this data, so convert it into more manageable data structures. So let me go to this website, which is those of you in economics and in other sciences might be familiar with this archive.org website, which is basically a print online repository for articles, new articles in many different fields. So here is a page for economics. So these are today's new articles in economics and on archive.org. And so I can actually get this data through request library. So here I'm going to say, please get all that information and save it in the variable R, right? So actually, let me paste all this code in here. So here, request hopefully was successful. So let me print the value of R, and it says response 2000. So what it means is that request was successful. So now everything is actually sitting inside this variable R. Then the entire web page, this web page, is sitting inside this variable R. But if you try to print it, so .text will extract text from this page, and let's print the first 200 characters, you'll see that it's actually not very easy to understand, because it's essentially HTML with lots of XML and HTML tags. So Beautiful Soup lets you pass that into something that is easier to read. So I pass it and save it into a variable called main page. And then if I try to print main page using the prettify function, it's still not really readable, right? So how do you work with that? Well, there are functions inside Beautiful Soup that lets you pass these very, very easily. But in order to use these functions, you actually have to go to the source code of your website and then try to visually look at the elements that might interest you. So, for example, on this website, I have articles, right? And here's the first article. So let me extract the title. And I could do this looking at this guy, but probably the easier way to do that would be to go to the source code of the page. So I'm going to go to Tools, Browser Tools in Firefox, and then Page Source. And then here, I'm going to search for the title. So here's my title. So here's actually the element in the HTML right here that gives me the title of this exact title on the actual page when rendered in a browser. So I can do this looking at the source code, and basically what I'm interested in is in this division class, so this division tag, right? So essentially this line of code that has this tag, div tag, and then class, this specific value of the class attribute. So starting with list title. And so if you don't like the idea of looking at the source code, you can also use other. There are other tools that let you simplify this. So there's a tool called Select Gadget, which is linked here from the notes, and it lets you essentially not automate but make it easier. So you will load your website into Select Gadget bookmarklet, and then as you mouse over different elements on the website, it will give you the code behind that element. But here the idea is that I'm interested in the titles, extracting the titles, right? So what I'm going to do is I'm going to inside my main page, which was passed by Beautiful Soup, I'm going to find all occurrences of a div tag with this specific value of the class attribute, right? So class is going to start with list title. And when I do this, that will actually output that into a variable called divs. And then if I inquire about the length of divs, that will give me the number of articles on this page. So today there are 18 new articles. And then if I want to strip, actual get text out of that, so let me take a look at the very first article, divs of 0 lets me strip text, right? Well, this is not very, very nice. So I can actually strip all those weird characters like end of line and spaces around the title. So I can do it like this, right? And then I can actually replace the title, the actual title semicolon with by using this function, right? So that actually gives me a nice title. And then the idea is that now I can automatically apply the same to all titles. So I can actually go through all titles on the website, and then I can extract all the titles. And I'm almost out of time, so let me just finish this example. So here I'm looking in the same main page, that I already downloaded once. So all the entire website is inside this variable. So I'm going through all titles, all authors, all subjects, and I'm extracting that into those 3 lists, right? So for example, if I'm going to see subjects, here are my subjects, right? So for the 18 articles on this website, here are the keywords or their subjects. And then I can put that all information into a data frame. So I take titles, authors, and subjects lists, and I put them into a data frame. And now the nice thing is with data frame, I can actually process this very quickly. So I can, for example, extract only those articles that have machine learning in the subject. And I do this using this code. So that will automatically give me only new papers from today in economics on the archive that have machine learning in their subject, right? So very, very easy to do. So visualization, I'm out of time, unfortunately, but what I want to say is there are multiple libraries for visualization. So you can go to the these websites, and it gives you tons and tons of examples. And here's, for example, the Python code to create this visualization. So there are several different libraries. One is called Matplotlib, the other one is called Plotly, then there's Seaborn and Plot9. Matplotlib is probably a good starting point because historically it was the first. The downside of Matplotlib, it does not give you interactivity. So it basically creates a static visualization. If you want to have some interactivity, then I have to look into Plotly or other libraries. And yeah, so here's a preview of tomorrow's 3D visualization workshop. But since I'm out of time, I'm going to stop here. And then a reminder, tomorrow is going to be a longer, not longer, sorry, it's going to be a short 1 hour, 1.5 hour, I can remember, 3D visualization session where I'm going to play with 3D visualizations in Python and in ParaView. And then in 10 days, so not next week, but February 26th to 28th, we're going to have a 6-hour 3D Python workshop with lots of exercises and lots of hands-on. So thank you very much.